We want to graph the solution to the system of inequalities. The solution to the system of inequalities is going to be the region containing the ordered pairs that satisfy both inequalities. So we will graph and shade the solution to both inequalities and determine the double shaded region. The first inequality is y is greater than or equal to x squared minus 4, which means we begin by graphing the corresponding equation, which is y equals x squared minus 4. And because the inequality is greater than or equal to, because of the equal part, we make a solid graph. The graph of y equals x squared minus 4 is the graph of y equals x squared shifted down 4 units. We're looking at the graphing form of a quadratic function. Notice that h is 0 and k is negative 4, and therefore the vertex is 0, negative 4. And since a is equal to positive 1, the parabola opens up. Let's begin by plotting the vertex on the coordinate plane. 0, negative 4 is here. We also know that the axis of symmetry is a vertical line passing through the vertex, and therefore the axis of symmetry is the y-axis, or x equals 0. This will be helpful when making the graph. And now let's find some additional points by making a table of values. We already know when x is equal to 0, y is equal to negative 4, which gave us the vertex. Let's also select x equals 1, 2, and 3. When x is 1, y is equal to 1 squared minus 4, which is negative 3. When x is 2, y is equal to 2 squared minus 4, which is 4 minus 4, which is 0. And when x is 3, y is equal to 3 squared minus 4, which is 9 minus 4, which is equal to 5. Let's plot 1, negative 3, which is here. But because we have the axis of symmetry, there's a corresponding point 1 unit to the left of the axis of symmetry, which is negative 1, negative 3, which is here. 2, 0 is on the x-axis. 2 units to the right of the axis of symmetry, which means there's a corresponding point 2 units to the left of the axis of symmetry, which is negative 2, 0. And then finally we have the point 3, 5, which is here. And therefore there's a corresponding point on the other side of the axis of symmetry, which is negative 3, 5. And now we graph the parabola, and again it's a solid graph. And now we need to determine whether we shade inside the parabola or outside the parabola, or above the parabola or below the parabola. Because we have y is greater than or equal to x squared minus 4, we are going to shade above or inside the parabola, but let's select a test point to verify. Let's use the test point 0, 0, the origin, which is here, inside the parabola, which means we substitute 0 for x and 0 for y into the original inequality, which gives us 0 is greater than or equal to 0 squared minus 4, which is 0 is greater than or equal to negative 4, which is true. Because this is true and the point is inside the parabola, we shade inside the parabola. So the solution to the first inequality is the region inside the parabola, as well as the points on the parabola, since we do have a solid graph. And now we need to graph the solution to y is less than negative 1/2 x plus 3. We begin by graphing the corresponding line y equals negative 1/2 x plus 3. Because b is equal to positive 3, the vertical intercept is 0, 3. And because m is equal to negative 1/2, the slope is negative 1 over positive 2. So let's first plot the vertical intercept, 0, 3, which is here. And because the slope is negative 1/2, which we can write as negative 1 over positive 2, from the vertical intercept, we go down 1, right 2, which we can repeat over and over again. And negative 1 over positive 2 is equivalent to positive 1 over negative 2, which means from the vertical intercept, we can also go up 1 and left 2 to find points on the left side. So up 1, left 2, up 1, left 2, and so on. Now again, we make a dashed line because the inequality is less than, not less than or equal to. And because we have y is less than negative 1/2 x plus 3, we shade below the dashed line. But again, let's go ahead and select the test point. Again, let's use the origin 0, 0. So we substitute 0 for x and 0 for y, which gives us 0 is less than negative 1/2 times 0 plus 3. Simplifying, we have 0 is less than positive 3, which is true. So because the ordered pair 0, 0 produced a true inequality and 0, 0 is below the line, we shade below the line. Now that we have the solution to both inequalities, the solution to the system is the double shaded region, which is the bounded region below the line and above the parabola, also including the points on the parabola over this region here because the graph is solid. So the solution to the system is this region here. This means any point in this region, including the points on the parabola in this region and not the points on the line in this region, will satisfy both inequalities. I hope you found this helpful.